Hey everyone, welcome back to the channel. This is the second episode of the Circle series for JEE Mains and Advanced. I'm Abhinav. I've done both my bachelor's and master's in electrical engineering from IIT Kharagpur. In the last episode, we have discussed equation of the circle in different forms and the parametric form of the circle, the equation of the circle passing through 3 points, position of a point with respect to circle, and the equation of tangent to the circle. So we also have discussed the equation of the circle when the endpoints of the diameter are given. So we have discussed all these concepts in the episode 1. So if you have any doubt in those concepts or if you have missed those concepts, you can always go back to episode 1 and take a look. So in this episode, which is the second episode of this series, we'll be discussing tangents and normals to a circle. Alright. So if you have ever felt that tangents and normals are confusing or that circle questions take too much time in exams, stay tuned. By the end of this video, you'll see how these concepts can actually become one of your strongest tools in coordinate geometry. So let us proceed. In the last video, we have discussed that if y is equals to mx plus c is a tangent to the circle x square plus y square is equal to a square. So this should be the condition that a, m and c should satisfy. So if you don't know how to derive this, go back to the first episode and check it out. So now, while deriving this condition, we ended up with this particular quadratic equation. Alright. So now let us take it a bit further. So we know the condition for y is equal to mx plus c to be the tangent to this particular circle. Now we will find out the coordinates of point of tangency as well. So this is your circle and this is your tangent. So what if you are asked to find out the coordinates of this particular point, which is your point of tangency? So this is your circle x square plus y square is equals to a square. So we have already discussed that since there is only one point of intersection, this quadratic equation should have a double root. So it means that the discriminant of the quadratic equation is 0, and that is how we got this particular condition. Now just plug in this condition into this equation. So you'll get m square plus 1 x square plus 2mcx plus a square. C square is a square plus a square m square minus a square. So this and this gets cancelled. So this is simply m square plus 1 x square plus 2mcx plus a square m square is equal to 0. Now this particular quadratic equation has a double root, which means the root of the derivative of this quadratic equation will be the root of this quadratic equation. So let us find the derivative. M square plus 1 x square is 2x plus 2mc, and the derivative of x is simply 1, and this should be is equal to 0. So the x that you find here will be minus 2mc divided by 2 multiplied by m square plus 1. This and this gets cancelled. So your x is simply minus mc divided by m square plus 1. So this is the root of this particular equation. Since the quadratic equation has the double root, so this will be the root of the quadratic equation as well. Therefore, the x coordinate of point of tangency is minus mc upon m square plus 1. Alright. Now we know c square is equals to a square multiplied by m square plus 1. So therefore, c can be square root of m square plus 1 multiplied by a, or it can be minus a multiplied by square root of m square plus 1. So there are two cases. Now if c is equals to this, then your x will be minus m multiplied by a into square root of m square plus 1 divided by square root of m square plus 1 whole square. So the denominator can be written as this. So this square and this term gets cancelled. So x is simply minus am upon square root of m square plus 1. Similarly, if you do the same thing here, you'll get x is equal to am upon square root of m square plus 1. Now put the values of x in the equation y is equals to mx plus c. Then you will get the values of y. So your x coordinate of point of tangency is this, and y coordinate will be whatever you get from this particular equation. We have already discussed why we have two values for c. So if you're not sure about this thing, go to the first episode and check it out. There I have clearly explained the reason behind c having two values. Alright, so let us proceed. So next concept is tangents from a point outside the circle. So you have a circle like this. Alright, so you have a circle like this, and you are drawing two tangents to this circle from an external point. Alright, the first tangent is T1, the second tangent is T2, and let's say the external point is P x1 y1. Alright, now you have to find out the equations of T1 and T2. So this is the problem statement. How do you do that? So we already know the equation of tangent to the circle is y is equal to mx plus or minus a into square root of m square plus 1. Now this can be written as y minus mx is equals to plus or minus square root of a into m square plus 1. If you square it on both sides, y minus mx whole square is equals to a multiplied by m square plus 1. So this is simply m square x square plus y square minus 2mxy minus am square, sorry, this is a square, minus a square m square minus a square is equals to 0. So now we are drawing these tangents from this particular point. So this equation should satisfy that particular point. So then if you plug in x1 and y1 into this equation, you will get minus a square m square minus a square is equals to 0. So now if you observe carefully, this is a quadratic equation in m. Alright, so this is simply m square into x1 square minus a square minus 2m x1 y1 plus y1 square minus a square. So this is a quadratic equation in m. If you solve this quadratic equation, you will get two values for m, which are m1 and m2. So m1 will be slope of this particular tangent and m2 will be the slope of another tangent. So once you get the slopes, you can substitute those slopes into this particular equation, and then you can easily get the equations of tangents. Alright, so you don't even have to substitute here. So you'll get the slopes, so m1 and m2. So you have a slope and you have a point, so you can easily use point slope form to get the equations. So let us solve a problem. So let us say you have a circle x square plus y square is equals to 1. So this is circle x square plus y square is equal to 1. The center is origin and radius is 1. So this point will be 1 comma 0 and this is minus 1 comma 0. Now I am asking you to find out the equations of tangents drawn to the circle from the point minus 2 comma 0. So you will get two tangents something like this. So this is T1, this is T2. So now you know the tangent equation. Y minus mx is equals to plus or minus a into square root of m square plus 1. Y minus mx whole square is equals to a square multiplied by m square plus 1. Now we have discussed that this point should satisfy this equation. So just substitute the coordinates. So 0 minus minus 2, and there is a minus sign already, and x is minus 2. So this will be 2m whole square is equals to a square. So here a square is simply 1. This is m square plus 1. So this is 4m square is equals to m square plus 1. This implies m square is equals to 1 upon 3, and this implies m is equals to plus or minus 1 by root 3. So we got two values for m. m1 is 1 by root 3, which is the slope of this particular tangent, and m2 is minus 1 by root 3, which is the slope of this particular tangent. Now you know the slope 1 by root 3 for this tangent, and you know the point that lie on this tangent. So you can easily use point slope form to find the equation of the tangent, and similarly for the tangent T2. I hope you're clear with this particular concept. So let us proceed. So the next concept is length of a tangent from a point to the circle. So you have a circle like this, all right? Sorry. So you have a circle like this, and from some external point, from some given external point, x1, y1, you are drawing a tangent to the circle. And let's say this is the point of tangency, and this is the center. Alright. Now, they are asking you to find out this length. Length of the tangent means the distance between the point of tangency and the external point. Alright. So now this is the equation of the generic circle that you have. So from that, the center can be written as minus g comma minus f. Since this is radius and this is tangent, so this angle will be 90 degrees. Alright. And this is radius. So let us say this point is A, the point of tangency is A, and the center is B. Now we can apply Pythagoras theorem in triangle PAB. So it says PA square plus AB square is equals to PB square. So what is PA square? PA square is the length that we have to find out. Let us say x, plus AB square is simply r square. PB square, you can use the distance formula between 2 points to find out PB square. So that will be x1 plus g whole square plus y1 plus f whole square. Alright. So x square. So the equation of the circle is given. From this, you know the radius is square root of g square plus f square minus c. So r square will be simply g square plus f square minus c. This will be, the right hand side will be x1 square plus g square plus 2x1g plus y1 square plus f square plus 2y1 f. Alright. G square and g square will get cancelled. F square and f square will get cancelled. And so your x that you have to find out, x square, is simply x1 square plus y1 square plus 2gx1 plus 2fy1 plus c. So x, your length of the tangent that you have to find out, is simply square root of x1 square plus y1 square plus 2gx1 plus 2fy1 plus c is equal to 0. Now if you carefully observe, if you consider this expression as s of xy, so s of xy is equal to this particular expression. If you consider that, so this length is simply, so this thing that you got here is simply square root of s of x1 y1. Alright. So you just have to substitute your point. If you put x is equal to, if you put x is equal to x1 and y is equal to y1 into this, you will get this particular thing. So if you assume this expression as s of x comma y, so this is simply square root of s of x comma y. Alright. And according to the convention, this thing is denoted as square root of s1. Alright. So s1 is nothing but your s of x1 comma y1. Alright. And this is the convention that we follow throughout the circles chapter. Alright. So this is how you find the length of the tangent from a point to the circle. Let us move ahead. Next, normal to the circle at a point. So let us say you have a circle. something like this. Now, at this point, let's say you're drawing normal to this circle. So let us first draw tangent. So this will be tangent. We know that normal is always perpendicular to tangent. So you'll have something like this. So this is your tangent and this is your normal. So normal is always perpendicular to the tangent. We also know that radius is always perpendicular to the tangent of the circle. So by that logic, we can conclude that normal always passes through the center of the circle, which in this case is minus g comma minus f. Alright. Now, let us say this point at which you are drawing the normal is p x1 y1. Now, you know 2 points on the normal. Alright. So the first point is p x1 y1 and the second point is the center. So you can easily find the slope. So using point slope form, we can write the equation of normal as, so the normal equation can be written as y minus y1 is equal to m. Slope is y1 plus f upon x1 plus g into x minus x1. This is the equation of normal. So this is how you find out the equation of normal to the circle. So when we solve few problems, you'll understand how to use all these things in the questions. So let us proceed to the next concept. Equation of tangent at a point. So let us say you have a circle, something like this. Previously in the first episode and in the beginning of the second episodes, we have seen the equation of the tangent of the form y is equal to mx plus c. So now let us say you are given a point p x1 y1. If you are asked to find out the equation of tangent at this particular point, how do you do that? So that's exactly what we are going to do. We'll first do it for the circle x square plus y square is equal to a square. Then we will generalize it for the circle x square plus y square plus 2gx plus 2fy plus c is equals to 0. Alright. So the center of the circle is simply 0 comma 0. So the slope of the normal, the slope of the radius, alright, the slope of the radius is y1 upon x1. So the slope of the tangent will be tangent slope will be simply minus x1 upon y1 because these two are perpendicular and their product must be is equals to minus 1. Now we know the slope of the tangent and there is a point on the tangent. So we can simply use point slope form. Y minus y1 is equals to m into x minus x1. So this is simply y1 minus y1 square is equals to minus x1 plus x1 square. So if you bring x1 to this side and if you send this y1 square to the other side, you'll get this particular equation. Since your x1 y1 lie on the circle, you can put those values here. So when you plug in x1 y1 into this equation, you'll get x1 square plus y1 square is equals to a square. So this is simply a square. So x1 plus y1 is equals to a square. So this is what we got. So this is the equation of tangent to a circle at a given point. So this can be written as x1 plus y1 minus a square is equal to 0. Now if you consider your circle equation given, so you have x square plus y square is equal to a square. So now this expression is denoted by t. So we will use this convention throughout circles. So how do we get t? Take the circle equation. Circle equation is simply x square plus y square minus a square is equal to 0. Now this can be written as x into x plus y into y minus a square is equal to 0. So replace one x and one y with x1 and y1. So x1 plus y1 minus a square is equal to 0. So now this will be your tangent equation. T is equals to 0. So T is this particular expression. Now, to generalize this concept for a general circle, x square plus y square plus 2gx plus 2fy plus c is equal to 0. So we can write this equation as x into x plus y into y, and write 2gx as gx plus gx and 2fy as fy plus fy plus c is equal to 0. Now replace one x with x1 and one y with y1, and similarly write this term as it is and replace this term, the x in this term, with x1. Write this term as it is and replace the y in this term with y1. Alright, so now if you rewrite that, it is simply xx1 plus y1 plus g into x plus x1 plus f into y plus y1 plus c is equal to 0. So this can be written as t is equal to 0, and t is this particular expression for this generic circle. So whenever you have to write the tangent equation at a particular point, you can use this particular technique. Alright, so you can solve this. You can just take the, instead of taking this equation, you can take this equation, replace the center with minus g comma minus f, and follow the same procedure. You will end up getting this particular equation for the tangent. I hope you guys are clear with this concept. So with this, we come to the end of this video. So we'll be discussing chord of contact and some questions and other concepts. So we will discuss chord of contact and some more concepts about circles, and we'll be solving some questions in the further episodes. So this is the end of episode 2. If you like the content that I'm making, do share it with your friends, subscribe the channel for more such content, and leave a like. And if you have any queries about the concepts that are explained or any generic query, please feel free to approach me in the comment section. Thank you very much. I'll meet you in the next episode.